When it comes to the great mysteries of our planet, few compare to those of the deep sea. 1,000 fathoms beneath the surface of the ocean, creatures of the deep have long been the subject of myth and legend. While no such thing as the mighty kraken truly haunts the seas, there may be some fact among the fiction. For giant creatures do exist in the deep, and leave many questions unanswered. How might these giant creatures have come to be? What is deep-sea gigantism? Deep-sea gigantism is best defined as a phenomenon in which deep-sea animals tend to grow to much larger sizes than their shallow water counterparts. Perhaps the most well-known example is the giant squid, which averages a length of 10 to 12 meters, whereas in contrast, most squids only measure around 60 centimeters long. In terms of weight, females max out at around 275 kilograms, making them the second heaviest invertebrate on the planet. Second to none other than the colossal squid, with an average length of 10 to 14 meters and a titanic weight of 495 kilograms. Some scientists speculate they can even reach up to 700 kilograms based on the sizes of beaks found in the stomachs of sperm whales. Another prime example of deep-sea gigantism is the isopod, a particular kind of crustacean with members of extremely diverse sizes. While most isopods are between 7 and 14 inches in length, the deep-sea dwelling giant isopod measures up to 2.5 feet long, a gargantuan in comparison to the pillbug, a commonly known terrestrial isopod that measures hardly an inch. Although size disparity already greatly exists among isopod species, deep-sea gigantism pushes its limits even further. Similarly, the Japanese spider crab is famous for its fearsome appearance and immense size. It boasts the largest leg span of all arthropods, reaching around 3.7 meters on average. But what makes these animals so large? Scientists believe that their massive sizes make them better suited to the deep-sea environment, but not for the reasons that one might expect. Generally in nature, a larger size provides advantages in hunting and competition. The deep sea, however, is a vastly different environment from most of nature, and as a result, the circumstances that drive deep-sea gigantism are not likely to be the same. One potential explanation involves oxygen levels in colder waters. A study in 2013 examined the interactions between frigid temperatures and body sizes in marine animals. It was found that colder waters do hold more oxygen. However, because cold water is much more viscous than warm water, its oxygen is ultimately much harder to take in. The deep sea, of course, can be extremely cold, and deep-sea gigantism adapts to these circumstances accordingly. Thanks to their larger body sizes, not only can these giant animals store more oxygen than smaller organisms, their increased surface area allows them to take in more water overall. Likewise, the study also notes that gigantism is more likely to occur in species with less efficient respiratory systems. Therefore, if respiration is an issue in colder waters, deep-sea gigantism may be the solution. Another possible, somewhat more general explanation regards advantages of larger body size in finding food. Because resources in the deep sea are scarce, most deep-sea creatures are suspension feeders. Rather than hunt live prey, they depend on excess food floating down from above. This concept is put to the test in one chapter of Body Size, the Structure and Function of Aquatic Ecosystems. Using the Reynolds number, a mathematical relationship between inertial and viscous forces, it concludes that the larger an animal is, the quicker and easier it can move through water. The ability to travel greater distances over time would ultimately help suspension feeders to find and collect more food. In addition, a low metabolism could allow larger creatures to gather more food without needing as much. Overall, it only makes sense that such a completely different means of survival would be cause for such extreme adaptations. In the end, these are only theories. ideas that strive to create a better understanding of a phenomenon that remains unexplained. As the name implies, these deep-sea giants won't be found near the surface anytime soon. Some, like the Japanese spider crab, are occasionally caught in fishing lines and even commercially fished. Others, like the colossal squid, have hardly been documented at all. For better or for worse, the mysteries of the deep sea remain elusive as one of the many great wonders of our world.